So now we're going to talk about our final method for solving quadratic equations, and that's solving using the quadratic formula. Up to this point, we've looked at solving by using the factoring method, by extracting the root, and also by completing the square. And now we're going to look at the quadratic formula and actually the derivation of the quadratic formula using the using the method of completing the square. So if we take our quadratic equation, ax squared plus bx plus c equals 0, where a, b, and c represent real numbers, and a is a non-zero number, I'm going to show you how we can solve this for x by completing the square, and in doing so, basically derive or come up with the quadratic formula. So if we're wanting to complete the square, what we talked about last time is that the need or the ease of completing the square if the lead coefficient is just 1. So since we have an a instead of a 1, that's going to be my first step, and it's dividing everything by a. So I'm going to divide both sides of the equation by a. So a divided by a is simply 1, so that first term is x squared plus b over a times x plus c over a equals 0 divided by a is simply 0. Now that we have the lead coefficient being 1, now we want to focus on getting a perfect square on the left-hand side. So to make it easier yet again, we're going to go ahead and get this c over a on the other side and leave a space for the value that completes the square. So if I subtract that c over a from both sides, I can rewrite this as x squared plus b over a times x plus something equals my negative c over a plus something. So I'm going to add some value to the left-hand side so that this trinomial is a perfect square. And then in order to make sure that I am creating an equivalent equation, whatever I add to the left, I have to add that same value to the right. So the idea, the reason that we complete the square is so that we can get the left-hand side to factor into two binomials that are the same, so that we can have something squared equals a number, so that we can then solve by extracting the root. So based on what we talked about last time, if we multiply this guy times this guy, we need to get our x squared, so that would be x and x. The product of these two need to be that number, and our inner and our outer have to add to this v over a. So again, I want these two to be the same so that I can write it as a binomial squared. So the only way I can get inner and outer to add to b over a and to be the same is if they're half of that value. So to find half of b over a, I can just take my b over a and multiply it by a half, and that would give me b over 2a. So this will be plus b over 2a, as will this. And so I will have x plus b over 2a quantity squared. So if I put the b over 2a here and here, again, the product of these two is what gives me this number here. So b over 2a times b over 2a, I have b squared over 4a squared. And that's the value that I'm going to add to both sides. Okay? So I have the left side looking like I want it to look, but now we need to work a little bit on the right-hand side. On the right-hand side, we have an addition of two fractions. And in order to add two fractions together, I'm going to have a common denominator. So let's work on getting those two denominators the same. I see that if I take this a and I multiply it by a 4a, then I'll have a times 4a, or 4a squared in this denominator, 4a squared in that denominator, and then I'll be able to add those fractions together. But if I multiply the denominator by 4a, I have to do the same to the numerator in order to write an equivalent fraction. So what I have on the right-hand side now, I've got negative 4ac over 4a squared plus b squared over 4a squared. And so I can add these two fractions together. My numerators, if they were like terms, I would combine them, but because they're not, I can't. And so I'm going to just leave that as b squared minus 4ac all over our common denominator 4a squared. Yes, I could have written that as negative 4ac plus b squared, but for those of you that have worked with the quadratic formula before or have seen it before, it's going to be more recognizable to you if I use this order. Okay, so now we have something squared equals a number, and because we have something squared equals a number, remember a, b, and c all represent real numbers, we can solve by taking the square root of both sides. So on the left-hand side, we've got x plus b over 2a equals, on the right-hand side, we're going to have plus or minus, and then we need to go ahead and break that into the square root of b squared minus 4ac over the square root of 4a squared. When we take the square root of a fraction, it's often easier to break it into the square root of the numerator divided by the square root of the denominator. I can't do anything to simplify that numerator. It needs to stay the square root of b squared minus 4ac, but in the denominator, 4a squared is a perfect square. So the square root of 4 is 2, and the square root of a squared is a. So this is 2a. And now my last step is getting x by itself. So I just have to subtract my b over 2a from both sides, and I will have x equals negative b over 2a plus or minus, that's still on your screen, okay, the square root of b squared minus 4ac all over 2a. And like we were dealing with before, since we have a common denominator, we can go ahead and rewrite that as a single fraction. And so we have x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a, which is the quadratic formula. Okay? So when we're working with solving quadratic equations, these equations that are in the form ax squared plus bx plus c equals 0, we can solve these by completing the square. We can solve actually every quadratic formula by completing the square, as long as we first work to get it into this form, which we know enough about algebraic manipulations that we can do that. So let's look at an example. Oh, first of all, there we go. There it is in big bold print. It can be used for solving equations in the form, and somehow that got flipped upside down. Ax squared plus bx plus c equals 0, where again, a, b, and c are real numbers and a is not equal to 0. This formula needs to be memorized. You will need it often enough that it is one that you should be able to just, click off the top of your head anytime you need it. So do make sure that you work on doing that quickly. You will definitely need it when it comes time for the test. So if I want you to solve this quadratic equation, x squared plus x plus 7, if you think about the four methods that we've learned, the first method was solved by factoring. X squared plus x plus 7 If you try it, you will see that that is not factorable. And because it's not factorable, I'm not going to be able to solve using the factoring method. Also, because of this x term, I can't just do simple manipulations to get it in the form of something squared equals a number, which is necessary to solve by extracting the root. However, I can solve by completing the square, and I can solve using the quadratic formula. These two methods are methods that always can be used. You can always solve by completing the square. You can always solve using the quadratic formula. Regardless of the method, it should always be that you get the same solution set. And I apologize if you hear my children screaming in the background. Sorry. Anyway, so solve by completing the square. So we have x squared plus x plus 7 equals 0. So I just want to demonstrate that you can do either. So to solve by completing the square, we would subtract the 7. So we'd have x squared plus x plus blank equals our negative 7 plus blank. So the idea is to add some value again so that this is a perfect square. Because if it's a perfect square, it'll factor into two binomials that are the same, and we can write it as that binomial squared. Remember, that is the big idea behind completing the square. So, figuring out what I can figure out what these binomials are just based off of those two terms. This times this has to be x squared, so those both have to be x. When I multiply these two numbers together, I have to get this number here, and when I add inner and outer, I need to get 1. So these need to be the same and add to 1, so therefore they must both be a half. So I'm going to put plus 1/2, and I can then write that as x plus 1/2 quantity squared. So this is the factorization of this. Therefore, the number that completes the square is the product of these two. 1/2 times 1/2 is 1/4. And because I added a fourth to the left, I have to add a fourth to the right to create an equivalent equation. And again, don't forget, you can just use your calculator to do, that calculation. Negative 7 is negative 7 over 1, or negative 28 over 4. So if we have negative 28 fourths plus 1/4, this value is going to be negative 27 fourths. Okay? So now we have our equation in the form something squared equals a number, which is what we're going for when we're completing the square. And then we can easily solve by simply taking the square root of both sides. So if I take the square root of both sides, I'm going to go ahead and bring this up here. I have x plus 1/2 equals plus or minus, working on that square root of negative 27 over 4. I'm going to focus on the 27 fourths first. 27 is not a perfect square, but it is divisible by the perfect square 9. So that would be 3 root 3. The square root of 4 is 2. And I know that if I take the square root of a negative, I have an I. So this would be plus or minus 3i root 3 all over 2. Getting x by itself, I have x equals, subtracting that 1/2 will give me negative 1/2 plus or minus 3i root 3 all over 2. And I can, if I want, since these are both the same denominator, I can go ahead and rewrite that also as negative 1 plus or minus 3i root 3 all over 2. Combined or not, either is sufficient. So these are the solutions to that quadratic equation. Okay, let's find the solutions using the method of the quadratic formula. So the quadratic formula is x equals the opposite of b, plus or minus the square root of b squared minus 4ac all over 2a. Again, we can only specify values for a, b, and c if our quadratic equation is simplified and equal to 0. So, simplified, if there were parentheses, we would need to get rid of them. If there were like terms to combine, we would need to combine them. But since we have our equation in the form ax squared plus bx plus c equals 0, right, this applies if equation is in form ax squared plus bx plus c equals 0, and it is. So our a, when we're trying to determine the value of a is the coefficient of the x squared, b is the coefficient of the x, and c is the constant. So in our formula, we're going to use a, we're going to use 1. For b, it will be 1. And for c, it's going to be 7. 1, 1, and 7. So plugging those values in. So you can read that as negative b or the opposite of b. In terms of use with the quadratic formula, it's easiest to read it as the opposite of b. So here, b is positive 1. The opposite of that is negative 1. So we have negative 1 plus or minus the square root of b squared minus 4 times the value of a times the value of c all over 2 times the value of a. So I'm just plugging in the values of a, b, and c that I was able to obtain from my equation. Find my pencil here. Alright, so doing our simplification, we have negative 1 plus or minus the square root of, so 1 squared is 1, 4 times 1 times 7, that's 28. So if we do 1 minus 28, we're going to get negative 27 as the value of the discriminant, which we'll talk about here in a minute, all over 2. Again, doing our simplification, 27 is not a perfect square, but it is divisible by the perfect square 9. So we have negative 1 plus or minus, so the square root of positive 27 would be 3 root 3. The square root of negative 27 is 3i root 3 because of the fact that the square root of negative 1 is I, all over 2. So you see, in comparison, solving by completing the square and solving by using the quadratic formula, we get the same solution set regardless of the method for solving. Sometimes it's going to be that completing the square is much more efficient and a lot faster than the quadratic formula, and other times it'll be the opposite. So, some people always want to go to the quadratic formula, and you can, but do keep in mind that there are other options that can be time-saving if you do work on those methods. I'm going to have a second part to this section, solve by completing the square, using the quadratic formula. I'll do some more examples, so stay tuned for the next video.